Hi everyone, this is Boyu from the Hong Kong University of Science Technology, Guangzhou. I'm here on behalf of my co-authors to share our paper, AniCraft. Rapid prototyping of 3D character animation plays a vital role in films, games, and every experience. It allows users to test and communicate ideas early on, helping them make informed decisions before investing substantial resources in final production. But to be honest, prototyping 3D character animation can be a real headache. For beginners, it's not user-friendly at all. So if you're a director with a big idea, you'd better be ready to dive into some pretty intimidating animation software. And even for pros, it's still a time-consuming process with endless keyframe tweaking. So basically, balancing the creativity with all of these technical problems is not an easy task. So in this project, we are trying to make this more easier. We let users to animate a virtual character just by using simple and easy-to-handle physical objects. So we place it in the mixed-reality setup to take advantage of natural 3D interaction and visualization. So just imagine you're holding and moving a physical object in your hand, and right beside you, a virtual character is mirroring your action. So it's pretty amazing, and I'm totally in love with the experience we've created with AniCraft. So previous work have tried to using physical proxy for character animation prototyping, which is definitely more novice-friendly and great for quick idea. Some approach capture parts of your motion, like your hand or your body, to animate the character. But when your body or hand doesn't share the same structure with the character, so things get tricky with some mapping issue. And others have experience with electronic sensors and mechanical setups, but it's not exactly someone that average person that can craft at home. So then there are some approach using everyday object, which is quite cool, but they're limited to only some simple animation, not the more complex skeleton animation we often used for character animation. So let me introduce AniCraft. It allows users to create full character skeleton animation using just about any object or material. So no complex device needed here. We just require consumer level device like some camera to capture the movement, some markers you can print at home, and a mixed reality headset for interaction. So we provide user with some pre-rigged character to get started, and so you can add your own custom character, but we didn't focus on that part of the interaction. And the idea here is actually the user create a physical proxy based on the character skeleton and attach markers to it for tracking. So you can then animate the character using performance-based method, means that the system will record real-time manipulation. And we also got a keyframe-based animation, where you can quickly pose the character and freeze it in different keyframes and let the system to create smooth interpolated animation in between. So here is a demo showing how a user uses metalware to craft a physical proxy with a tiger. So following his skeleton, and you can see how he attached markers to different parts. And notice that how the individual indicator match the marker ideas with specific part of the tiger. And next, the user can animate a tiger using physical proxy. So here's how it works. The user poses the tiger to create a keyframe by manipulating the proxy. After some iterations, and you can see, the user is prototyping, and you can see the frozen tiger pose at each keyframe, and we let user to adjust the interval between them. And finally, they generate animation. You can see the tiger is jumping right now. Here we showcase a variety of examples where different proxies are used for different characters, including some real creative combination. So in certain cases, the proxy can even be something as simple as separated cubes. So the possibilities are pretty flexible. And for animation, user can directly handle the physical proxy, but in more creative way, they can also manipulate indirectly. So for example, here we set up a pulley system to flap the bird's wing Or we use a block suspended by rope to simulate the swing under forced gravity, so it's open up a lot of fun. And for mapping strategy, we support linking the marker position to inverse kinematic targets. So there are two modes for this. In pose mode, you can control every part of the character in detail using the physical proxy. But sometimes you don't need that much precision, like we just want to control the two faces for a working animation. So for those cases, we also offer the motion mode, where you can only manage the key parts. In some cases, we are trying to focus on more whole body movement rather than just a specific poses. So for this, we allow users to control the character by having to follow a target or a trajectory that's drawn by the user, so making it easier to animate a large-scale motion. For our evaluation, we conduct a comparative study to see how AniCraft stack up against traditional desktop-based systems in facility 3D character animation prototyping. We asked 12 participants, both novice and professionals, to complete tasks like making a chicken walking or a butterfly flying using both AniCraft and Unity system. So afterwards, they fill out a questionnaire to assess the various metrics between the two systems, followed by a semi-structured interview. So the result here shows that the user found it much more natural and intuitive to pose a character with 3D physical interaction compared to traditional 2D interface. And we also track the time spent on crafting the proxy and creating the animation. So most users noticed that our workflow was quite engaging. We also conduct a semi-open exploration study using a range of materials like metalware, origami, clay, and wooden cubes. The participants had 50 minutes to create physical proxies for characters such as human, birds, and dogs. So to keep the focus, we limited the material to some common items that are found in everyday life, and participants were encouraged to combine at least 2 different materials. After crafting each proxy, they animate their creation using our system. So here are some physical proxy made by our user. So like you can see that here, here's a human avatar, and it's for bird avatar, and it's for dog avatar. Our finding reveals that the choice of a material for a physical proxy significantly affects both animation quality and user experience. So metalware emerged as a favorable for its ease of manipulation and precision, whereas the origami presents some challenges due to its complexity. Interestingly, participants discovered that combining material, like using the wooden blocks for stable alongside wire for flexibility, enhances the presence of their character. So overall, this insight underscores the importance of the material selection in achieving effective animation and conveying intended movement. We've also demonstrated some applications of AniCraft. As we mentioned earlier, character animation prototyping is a key part of pre-visualization, which is a rough 3D animation that lets director and team to play around with the idea, but it's not just about the animating the character. It's also about animating the camera motion. So we take it a further step and let you to control the camera using the physical proxy, like you are holding a real camera here. By the way, the dragon here is animated by our system in advance, as you can also see the real-time camera preview. Another application is the interaction between the multiple characters. Our system also supports multiple characters in a scene, so letting you create really fun interaction animation. So for example, here we attached magnet to physical proxy, so when the eagle and the cat get closer, the magnet pulls them together just like an eagle swooping and catch a cat in its talon. So we've also considered how the character interact with the scene. Since the virtual object doesn't share the physical world, we use physical proxy to represent the virtual scene, providing tangible support and interaction for the users. So in conclusion, the key takeaways are the following. The first is prioritize intuitive 3D interaction to make animation prototyping more accessible, especially for the beginners who may not have prior experience with complex character animation tools. So this will allow for more seamless and engaging creative process. And the second one is enable rapid prototyping by supporting multiple level detail from a specific pose to pose with motion or just the movement. So this flexibility accommodates a range of creative deep animation process. And the last one is that we should more focus on the impact of the material used in making physical proxy as a character animation. So thanks. I'd like to hear any questions.
Hi, thank you for your great work. So I was wondering if there's any way to convert the animation prototyping into keyframe animations so that animators can use them for their artworks in the future.
So you mean convey the character into the...
Convert the character animations into keyframe animations.
Oh, you mean character animation. So we also support keyframe-based animation system. So it's actually an inverse way, I think you mean. So we record a character animation first and get it back to a keyframe. Is that what you mean?
Yeah.
Yeah, that's a great point, I think. When consider this because it may provide more detailed keyframed animation. Yeah, we'll consider this. Thank you.
Thank you.
Hi, Gabriel Lipkowitz from Stanford. This is very beautiful work. I think that one of the most tedious aspects of animation is the simulation of soft body physics. And some of the materials that you use are indeed soft. And I was wondering if, in addition to user interactions to program animations, I think a very compelling application of your system would be able to directly input the interactions between clay and other soft materials, for instance, into an animation. I was wondering if you thought about that in your system as a tool for animators as well.
Yeah, for soft, it's actually we use marker in systems. So for soft or deformable materials, it's actually quite hard because we are only tracking the marker position here, but not focusing much on the something soft. And I think it would be quite good if in the future we can directly track the material just without the marker, and we can not tracking the skeleton, but or the deformation. Yeah, something like that. Thank you.
Yeah, let's thank Boyu again.